Good morning to Madam Manisa. So today I will present the heuristic construction in mathematics. So in the presentation, I will present about the meaning of heuristic and three level of heuristic question, which is easy, intermediate, and advanced level. First of all, let me introduce about what is heuristic construction. Based on the Poya in 1945, heuristic construction refers to the use of flexible experience-based strategy to solve problems, especially when there is no clear or direct method. This approach was introduced by George Poya, who emphasized understanding the problem, planning, solving, and reflecting as key steps in problem solving. Heuristic encourage logical reasoning and creativity, particularly in non-routine mathematical tasks. So why heuristic construction is important to us, as it can encourage our logical reasoning and systematic problem solving. Heuristic construction also essential for mathematics education and real-world problem solving. So now let us see about the easy level heuristic question, which is a person has 10 coins, some are 1 rupee coins and the rest are 2 rupee coins. If the total value is 16 rupees, how many 1 rupee and 2 rupee coins does the person have? This question involved in CL04, which is applying. So to solve this question, we have 3 solutions. The first solution is make 2 linear equations and solve it. First, let x become number of 1 rupee coins and y become 2 rupee coins. And we set up 2 equations, which is the equation of total coins and the equation of total value, which is x plus y equal to 10, which is the total coins, and x plus 2y equal to 16, which is total value. From the equation 1, we can get that y equal to 10 minus x, and we substitute the equation 1 and we substitute the new equation into equation 2, so we can get that x plus 2 times 10 minus x equal to 16, and x, after we expand it, we get x plus 20 minus 2x equals to 16, and after we divide, we can get negative x equal to negative 4, so x equal to 4, and then we calculate the value of y and we get y equal to 6y, and the answer is 4 1 rupee coins and 6 2 rupee coins. So now let us see about the solution 2, which is make a table and try and error. So we assume that we got 3 1 rupee coins and 7 2 rupee coins. After we add it, the total value becomes 17. So this is not equal to 16 and we can reject it. And we try to 4 1 rupee coins and 6 2 rupee coins, and after we add it, we get that the total value of these coins are 16, and we can say that this is the correct combination found. And the solution 3 is using graphing. So we define as x equal to number of 1 rupee coins and y-axis equal to number of 2 rupee coins, and after we draw the graph by using the equation from the solution 1, we can get that the graph have the 2 lines have one intersection point, which is the answer. So based on the graph that I show, the number of 1 rupee coin is 4 and the number of 2 rupee coins is 6. In this easy level heuristic question, we have 4 computational thinking concepts used, which is decomposition, pattern recognition, abstraction and algorithmic thinking. For decomposition, we can solve the problem by breaking down the problem into smaller parts, like total number of coin and also the total value of the coin. For the pattern of recognition, we can try to recognizing that is a type of problem that often involve forming and solving a system of equation. For abstraction, we can try to ignore the coin appearance or other irrelevant details and focusing only the number of coins and their individual values, which is 1 rupee and 2 rupee and the total value of them. For the algorithmic thinking, we can try to creating a step-by-step method to solve and get the final answer. For this question, this involve Bloom taxonomy level, which is CL04, which is applied. So why this easy level question is CL04, as student can apply algebraic concepts such as equation substitution to a real-world context when they try to buy something, and it not just solving mechanically, and they can try to use strategy and structure to find out the final answer. So now let us see about the intermediate level of heuristic question. The question is, a man is planning to climb a staircase with 5 steps. He can take either 1 or 2 steps at a time. In how many distinct ways can he reach the top? This question is involved in CL05, which is evaluating. So this question also have 3 solutions to get the answer. So now let us see about the first solution, which is mathematical sentence. So if we want to take 1 step, so the ways to reach the step is n-1, and if we want to take 2 steps, so the ways to reach the step is n-2. So based on the assumption we get, we can form a equation which is fn equal to fn-1 plus fn-2. So the base cases is, if we want to take 1 step, so we have one way which is f1 equal to 1, and if we want to take 2 steps, so the 2 step is f2, and we have 2 ways. So now based on the base cases and the formula we get, we can calculate f3, f4 and f5. So for the f3, based on the formula, we can get that f3 equal to f2 plus f1. So we can get that f3 equal to 1 plus 2, which is 3, and f4, which is f3 plus f2. So we can get that f4 equal to 3 plus 2, which is equal to 5 ways. And the last step is step 5, which is equal to f5. So based on the equation, we can get that f5 equal to f4 plus f3, so which is 5 plus 3 ways. So the final answer to get the 5 step by using 1 step or 2 step is 8 ways to get the top. So let us see about the solution 2. For the solution 2 is like try and error. First, we can list all the valid combination to take the step. For the first one, we assume that we take all 1 step, so we can get 1 5 times. So this is the first way, and the second is 3 1 times and 1 2 times, and so the two combination until the 4 combination is we use 4 1 times 2 step, and the 3 and the last 3 we use 2 steps to get the file. After we list all the combination that we have, we can calculate the total ways that we list, which is the same answer like the solution 1 is 8 ways. So for the solution 3, we can try to treat the problem as how many ways we can arrange a sequence of 1 step and 2 steps that sum to 5. So it lies near like the solution 3, but quite different. So for 5 1 step, we can just take 1 ways, and for the 3 1 step and 1 2 step, we can choose the position of 2 step, which we can take 4 times for the position for 2 step. And the third is we take 1 times 1 step and 2 times 2 step, and we can choose the position of for 1 step is 3. So after we calculate all the ways, which is 1 ways plus 4 ways plus 3 ways, we get the same answer like the other solution, which is 8 ways. So in this intermediate level of heuristic question, we also involve in 4 computational thinking concept use, which is decomposition, pattern recognition, abstraction, and also algorithmic thinking. In decomposition, we can try to solve the question by breaking down the problem by state counts, and the pattern recognition, if we see more detail, we can know that this is the 509C pattern. And for the abstraction, this we just need to focus only the sequence of move, and we can try to ignore the place that the man goes. And the algorithmic thinking, we can designing a method or a cursive formula to solve the question. So in this question, the Bloom taxonomy level of this question is CRO5, which is evaluating. So why this question falls under the evaluate level? Because the student can be expected to determine and apply a suitable method, such as a recursion or a combinatorial approach. They can analyze the efficiency or suitability of the method and justify their choice to compute the number of distinct ways that the man can reach the top of the staircase. And the last question is advanced level of heuristic question. So the question is, you are given the digit 1, 3, 4, 6, 7, 9, and we can use any 4 of this digit only once each, and any mathematical operation such as addition, subtraction, multiplication, division, exponential, or brackets. So we can use this mathematical operation to create a different expression that the result can be in the number of 100. So this question is involved in CRO6, which is creating. So for the first solution, we can try to use pattern recognition and also mathematical sentence. So we can try like 9 plus 6 times 7 plus 1 will equal to 15 times 8. So the answer is 120. This is too high for the result, and we can try to use 9 plus 1 times 7 plus 3, and we can get that the answer is 10 times 10, and the final answer is 100, which is the result that we want. For the solution 2, we can try to use the method work backward and the logical thinking. So we start from the final result, which is 100, and we can think that what two number multiply to get 100. So after we think, we can get that 10 times 10 is equal to 100. After that, we think that how we can build 10 times 10 twice using the digit. So after we think, we can know that we get 3 plus 7 is equal to 10 and 4 plus 6 equal to 10, and we try to, and after we get these four numbers, and we multiply it, and we get the result also, which is 100. And the solution 3 is we use checklist and try and error. We can try all the 4-digit combos. Okay, so first we try 7 times 9 plus 4 times 6, and we get 42 plus 24 equal to 66. So this is the wrong combination. And after this, we try 3 plus 7 times 9 plus 6, and we get 10 times 9 plus 6. After we multiply again, we get 90 plus 6 equal to 96. So this almost 100, but it's still wrong. And the third try, we try to use 9 plus 6 plus 4 plus 1 times 5. So after we plus all the number in the bracket, we can get 20 times 5. And after we times the answer, we can get that the answer is 100, which is the result we need. So in this advanced level of heuristic question, we can get that there is also 4 computation thinking concepts used, which is decomposition, pattern recognition, abstraction, and algorithmic thinking. For the decomposition, we can try to breaking down the target, which is number 100, into manageable parts. For the pattern of recognition, we can try to looking for the pattern in how this 4 numbers combine or repeat structure in operation to get the answer. For the abstraction, we ignore the unnecessary details like digit order or decimal issues, and we just need to focusing on the core logic. And for the last, algorithmic thinking, we can try to creating a repeatable approach to get the final result. For this question, is involved in Bloom taxonomy level in CL of 6, which is creating. So why this question is involved in creating? Because the student must generate original expression using a set of constraints, only 4 digits, only once, any operation. They are designing new solution and constructing multiple possible outcomes. It goes beyond applying no procedure. They are inventing and testing combination to achieve a target, which is get the digit 100.
In conclusion, computational thinking skills and heuristic approaches play a crucial role in shaping modern education, empowering teachers, and addressing global challenges. By integrating these skills into teaching and learning, teachers can foster problem-solving abilities, drive educational innovation, and nurture a new generation of inventors. Mathematics, as a universal language, serves as a powerful tool in this transformation, equipping individuals with the logical reasoning and adaptability needed to navigate an evolving world.